Next to me is Gustav Björksten, and he'll be telling us about open source biofuel. Please, Gustav.
Thank you, and I apologize for the delay. So, this talk is about looking at the possibility of very small-scale open source biofuel production. So it's just a matter of housekeeping. Life is too short for fancy slides. I hope you like black text on white background, because that's mostly what you're going to get. So what this talk will cover, we're fucked, the global context, why we, the people, are the only solution, what it means to obtain personal security in all things, a ridiculously brief history of motorcar fuels, some case studies, Bougainville and Brazil, why biofuels, what those fuels are, what needs to be done to get your car running on them, and a plan to make this part of the revolution. So, we're fucked. We are well past peak oil. That happened a long time ago. Companies are using ever more destructive means to extract fossil fuels. And this is having an effect on the immediate environment, as well as a further reaching effect in terms of things like transportation and whatever of those fossil fuels. We're also way past 350 parts per million of CO2 in the atmosphere. That was the level that was set as being the safe point. We're a long way past that now, and we're in very much uncharted territory. Climate change is here. I believe it's here. Back in my home country, I see evidence of it. In one state, the state of New South Wales, the disaster recovery expenditure has tripled in the last 6 years. The 2014 expenditure, they had allocated 95 million Australian dollars, and they spent $375 million. And just this year, as of April, they had spent the entire year's allocated budget for disaster recovery, and that occurred in a single storm in Sydney. In Victoria, the state I'm from, there's been a drought for 15 years. There's a whole generation of kids who have never seen the many fountains of Melbourne bubbling with water. And after this 15-year drought, there was the first major deluge of water, and it caused a massive flood. And it was billed as a once in 200 years flood. And then just a few months later, in exactly the same area of the state of Victoria, there was another once in 200 years flood. And I think this is the kind of thing that we're going to see everywhere. I think climate change is real. I'm now living in Costa Rica. There's the first ever recorded drought in Guanacaste, the western province of Costa Rica. So I think we're in a lot of trouble. Why are we the only solution? Because governments and industry around the world have failed us. Climate change is a global phenomenon. It doesn't respect national borders. And for us to effectively combat climate change, all governments would have to work together. And from what I've seen so far, there's not a lot of ability or desire to do that. So we may be looking at the 6th extinction level event. In Earth's history, there have been 5 previously. About a month ago, a scientist who was talking about climate change broke down on camera because she believes that it is probably too late and that we are heading for the 6th extinction level event. Now, I don't know if we are or not. I do believe that the situation is critical and that we must do something. I want to do something, and that's why I've looked at where my interests lie and what my capabilities are, and have come up with this proposal to try and do something about it. So we the people, we must take matters into our own hands because we may be humanity's last hope. I'll just take a tangent for a second. I'm a believer in personal security in all things. I have an interest in a lot of these. I would like to see the people of the world rely less on governments and big corporations for all of the basic things that we rely on to live. So things like food, grow it yourself. Instead of monoculture farms, let's get into permaculture, and so on. Water independence, collect, filter, store, reuse yourself. Shelters, build simple local material shelters. Obviously there's alternative energy, transport and fuel, which is what this talk is going to be about. Economic independence, so cutting out the middleman of the big financial organizations, the ones that fucked us over with the global financial crisis. Let's go peer-to-peer. Let's use cryptocurrencies. Let's create local currencies. And the last one there, healing, well-being, and evolutionary independence. But let's talk about transport and fuel. A ridiculously brief history of motor fuels. We have this idea that cars run on gasoline or petrodiesel. But when the whole idea of cars started, and in the early days of cars, there were experiments with a whole range of different fuels. Steam was the first one. It's difficult to carry enough fuel to get around with steam. So they went on to other things like bioethanol, straight vegetable oil, electricity. There were electric cars way back in the earliest days of cars. We think of, Tesla as a brand new thing, but not so much. And cars back then even ran on gasoline and diesel. The 1908 Model T Ford was a flex fuel car. It was actually designed for bioethanol, but it could also run on gasoline. But it was optimized for bioethanol. And Henry Ford had a vision. He saw the farmers of America on their average-sized farms back in those days of 125 to 250 acres, growing 1 acre of potatoes and using that 1 acre to produce bioethanol and run all the farm machinery that they required to farm the remainder of their farm. So this is an old idea. Rudolf Diesel first tried to design engines for straight vegetable oil before moving to petrodiesel. So again, that's another early inventor that was looking at these alternatives. A couple of stories. The Brazil government has moved. They actually, legislated and made decisions and made the possibility of being a 100% bioethanol country. They use sugarcane as the feedstock. There's arguments for and against that. You have to grow lots of sugarcane. There's debates about whether that land could be better used for other things, but the fact is that they have done it. All cars sold in Brazil must be flex fuel. And at every gas station, the citizens have the choice of which fuel they want to buy. Gasoline is still available, but every citizen has the choice. If the shit hits the fan and fossil fuels are no longer cost-effective or run out or cannot be used because of the effect on the planet, Brazil will be the only country in the world that will be able to cope with that situation. Another interesting case study is the island of Bougainville in the Pacific. They had a fight for their independence from New Guinea because there was nothing that really made them, think that they should be part of New Guinea. They weren't culturally part of it. They weren't racially part of it. Bougainville was just given to New Guinea after the Second World War, like certain situations elsewhere in the world. So they had this fight for independence, and as part of that fight, they were blockaded. Their island was blockaded by the Papua New Guinean Navy with support from Australia, who has mining interests on Bougainville. And so they couldn't get any supplies, including fuel. So they made their own. And they made it with coconuts. They took their coconuts and some very, very, very basic equipment, a drum, put the meat of the coconuts in the drum, jump up and down on it until it turns to liquid, put a hole in the bottom of the drum, drain it across some corrugated iron into another process, and so on. And that's the way they were able to brew their own biodiesel and keep their vehicles going and keep their revolution going, and ultimately they got autonomous rule. So alt fuels. Biofuels are a renewable resource. I'm interested not in growing large amounts of biomass to make fuel, because in many places we have that biomass already. It's waste product. It can be waste vegetable oil, as is used by restaurants or whatever. You can turn that into biodiesel. In Costa Rica, we have an enormous amount of waste biomass. It comes from things like food production, the waste bits of the food production. And it's a problem of what to do with it, but we could be making that into bioethanol. So it's carbon neutral to produce. It's much cleaner when burnt. It's even much cleaner when burnt when you blend it with gasoline or petrodiesel. Even if you have 10% or 20% of a biofuel mixed with your petrochemicals, the burn result is much cleaner. So there's less environmental impact, it's less of it spills, it's much more biodegradable. So it has advantages there. As I mentioned, many countries have bio-waste ready at hand. It's cheaper to produce, and I'm a rev head. There's no way I'm going to drive a fucking Prius. I like the idea, I like the planet, I want to save the planet, but a Prius is just not commensurate with my testosterone levels. So I want to feel like I'm burned. So the first potential fuel we have is straight vegetable oil or waste vegetable oil. So ideally we would take the waste vegetable oil. The processing is very minimal. You just filter it. But what are the cons of using that in cars? It's only going to work in diesel engines. You have to mechanically modify the cars. The engine life will be questionable, in my opinion. I've seen some pretty disastrous results over time. And there's most definitely mileage and performance penalties, so not great. You can do blending. That is possible. Again, I think it's less than ideal. Just because, you're putting your engine and everything at some risk. But there's two options you can go for with waste vegetable oil or straight vegetable oil. A double tank. So you have your normal diesel tank and you add an extra tank and you start driving on diesel. And when the engine and everything is warm, you flick a switch and you change over to the vegetable oil. You need to do that because you need to heat the vegetable oil to get it viscous enough to actually go through the car and run the car. And the bigger problem with this is that when you want to stop, so a couple of kilometres before you stop, you need to switch back to diesel to clean out the system. So if you have to stop suddenly and leave it stop for a while, you might have difficulty restarting. The other option is a single tank, but if you have a single tank, you'll need to also preheat the fuel before you start the vehicle to get it to go, around the circuits of the vehicle. So the process is extremely simple. You filter your waste vegetable oil into straight vegetable oil, and you're good to go. Store and pump. Biodiesel. Biodiesel, you get better mileage than petrodiesel. It cleans the engine. It has a much higher solvent content. The vehicle modification is minimal, so certainly for older vehicles there should be no modification. There just may be some issues with very modern diesels. Biodiesel can also be blended, but I like to use it straight. The cons, it's going to clean your engine and it's going to clean a lot of muck out in a short space of time. So when you switch to biodiesel, you have to change the fuel filter several times. It's also a good idea to carry a spare, and you can't use rubber hoses because they will deteriorate pretty rapidly. Now, to me, there's no point in producing biodiesel unless it's of the highest standard. And these are the standards that are out there. ASTM D6751 is the US standard. There's different standards here in Europe and Germany, but they are all pretty much equivalent. They differ a little bit here and there, but for our purposes, we can take any one of those, and if we can meet those standards, that will be fine. So the theory behind these standards is that if you reach that standard, the diesel should run in any diesel engine. That's great theory, and there was a time, I believe, when that was true. I'm just not sure that it is true today. So older engines, this is a heuristic rule. Older engines are much more tolerant than newer ones. Certainly industrial engines are very tolerant. The industrial generators around this camp that are providing us with all our power, there's absolutely no reason why they couldn't be running on straight biodiesel. My truck's a 91 with a 95 engine. It's just fine. But, the really modern common rail direct injection diesel engines use extremely high pressures at the injectors. 30,000 psi is not uncommon. And I do believe that some people find that they cannot run on straight biodiesel without having some injection problems. But I also believe that those people can blend with 50-50 and it will work. Unfortunately, I don't have a modern car to test with, otherwise I would. But we need more people to get into this and test it, and and publish the results. So to make biodiesel, we take a waste vegetable oil or a straight vegetable oil. We put it through the filtration process if it's waste. So we go through 600 micron, 400 micron, 200 micron, 100 micron filters. And then we heat it and put it through a pressurized 5 micron filter before putting it into the reactor. So the reactor is where we turn that vegetable oil into biodiesel, and we make that reaction occur by using a catalyst, which is methanol and sodium hydroxide, and it splits the vegetable oil into biodiesel and glycerol. So glycerol can be used for all kinds of things. It can be used to make soap. It can actually be used as an input to make another sort of fuel, ethyl ester-based fuel. It can also be used for all kinds of other things that, glycerol can become glycerine. You mix nitrate with that, it becomes nitroglycerine. You add a gel or a clay, it becomes dynamite or gelignite. But, apart from that, let's hope we don't need that for the revolution. Let's stick to fuel. So after we've had our reaction and we've split the oil into those two parts, we pull off the glycerol, and then we take the biodiesel and we put it through an acid pre-wash, and then we put it through a wash, and then we put it through another wash, or some people call it a dry, and we should end up with our standard spec biodiesel. And then it's a matter of store and pump. You need to test your waste vegetable oil before you start. There's visual and filter tests. If it fails those, don't go any further, throw it away, find a different source of waste vegetable oil. It needs to be reasonable quality, otherwise you're just fighting an uphill battle. If it has too much food particulates in it, or if it's been heated and used to death, it's not going to work for you as biodiesel. You also do a titration test, and that gives you the potential for the reaction in the reactor, and so it needs to be within certain specs for you to get a 98% or better reaction into the glycerol and biodiesel. You also do a titration test after the reaction, and that shows you what the success of the reaction is. And then at the end of the process, you want to do some quality testing so that you know how far off the standard you are. Now, to get it properly tested in a lab, it's going to cost about $1,000 a throw. So there are some very basic tests mentioned there, which will give you a good indication of whether you're meeting the standard or not without having to pay that amount of money. So bioethanol, pros. It runs your engine at a cooler temperature. There may be performance gains for high-performance engines. I certainly heard about someone who owns a Koenigsegg supercar and runs it on straight bioethanol, and the performance figures were much greater than running that on gasoline. It also has anti-knock characteristics, but there are some questions about it. Worse gas mileage is certainly one. The fermentation produces some CO2, so you need to find ways to mitigate that. Since the exercise really is to reduce CO2. Again, you can't use rubber hoses, and you may need to tune or modify your ECU to get it to run on bioethanol or be optimized. So the process, I'm not so familiar with bioethanol. I have a a close friend in Costa Rica who is a specialist in bioethanol. I'll show you his plant in a later slide. But it involves milling. So you take the biomass, you mulch it up, you then cook it and liquefy it, then you ferment it. So it requires yeasts and enzymes. If it's not a very sugary feedstock, you'll have to add sugar. And then you distill it and put it through a sieve. If you're doing this commercially, you would add a denaturant. If you're doing this yourself, you wouldn't have to do that. The only reason they do that is to stop people from drinking it, because it is an alcohol. And then you store and pump. So biomethanol, I might just really skip through this because there's a lot more unknowns about biomethanol. There seem to be arguments saying that over the full life of creating and burning the biomethanol, you produce less CO2 than gasoline, but there's also other studies that show that it releases a great deal more CO2. So I don't know, I haven't really done the science to work that one out, but it is a possible fuel as well. That's the process. It's a much more involved process. That's why, certainly for myself, I'm going to concentrate on biodiesel. As I mentioned, my friend Peter is concentrating on bioethanol. But, I mention this just for the sake of completion. So sub-processes, the idea is to be as self-sufficient as possible. So wherever we can create all of the auxiliary processes ourselves, we should do that. So, distilled water is required in both biodiesel and bioethanol. So we want to make sure that we have a source of that. The production of bioethanol also produces distilled water, so that's handy. As I mentioned before, you need enzymes, yeasts, and possibly sugars. My friend currently is importing that from Europe, but I think that given that we're in Costa Rica, it would be much better if we could source local things that did the same job. The same is true for the chemicals. If we can source those or make those locally, then that's better. And heat. This is one that really cracks me up. If you look at YouTube videos of distilling bioethanol, what you will see in almost every video is the use of propane to heat the still. So here we have someone who wants to get away from fossil fuels in their vehicle and produce a biofuel, but they produce the biofuel by burning fossil fuel. So, to me, that doesn't make a lot of sense. So we need to find a source of heat that makes sense. So using that glycerol to create another fuel for the process, something like that would be ideal. So modern vehicles, 96 and newer, all vehicles have OBD2. They all have the diagnostics port. So the theory is that all modern cars can run on bioethanol, at least as a blend, if not straight. But no cars are optimized for this. Not even flex fuel cars are optimized for biofuels. They're optimized for gasoline. So, there's a lot of work that needs to be done in terms of chip tuning to tune the ECU to work, optimized for biofuels, or reprogram to run on biofuels. So software-only modification, but it'll be interesting to see how difficult or easy that is. Older EFI cars, again, they should all be able to run on bioethanol, but it's a much, much more difficult problem to reverse engineer the ECUs and reprogram them. Back Back then, there were no common standards for these things. I have myself rewritten the ECU of an old GMC truck that was nominally labelled as OBD1, not that that was any real standard. And I can tell you it was a lot of work. And really old carburetor cars. So again, old cars can be modified to run on bioethanol. That link there shows a story of someone modifying a 1969 Dodge Dart to run on ethanol. You hack into the carburetor and a few other things like that, and you can get it to work. So how? How are we going to do this? I want it to be cheap. I want it to be small. I want it to be simple to construct and simple to understand. I want it to be built with local materials. I want it where it requires some machining or manufacturing. I want that to be locally sourced. And I want the whole thing to be open source. So that's my vision. So cheap. There are brilliant people out there with brilliant solutions. I don't know if any of you are familiar with earthships. These are houses that heat and cool themselves, that treat their own sewerage, that grow their own food, that power themselves. They're completely off the grid. They're awesome. The inventor of the earthships claims that he wants it to be a viral thing and he wants everyone to build one. And yet he charges $8,000 for basic plans and $120,000 US for customized plans. So I don't know about you, but that puts it out of scope for much of the world. So I call that a guilt appeaser. If you are one of the 1% in the US and you have polluted the planet plenty, you can now appease your guilt by having your own earthship. So it's got to be really cheap. I also want it to be small. I want it to be as close to personal as possible. That's most definitely the case with biodiesel. You can make it in very small amounts. It's a very simple process. You can do it in your garage. It's not a problem. Bioethanol is more difficult, and that's what we're starting to work on now. But if it's small, if it's personal, you present a smaller target to the petro interests that are out there. We need to be distributed, much like the internet. We need personal commitment and buy-in from the people that are going to be producing the diesel. So, I want to see people building it themselves. And with that model, it'll be very difficult to stop. If we all start making our own fuel, they'll have to start to listen. Simple to construct. Ideally, no specialist skills required. I'd like to see kits offered to help people. I'd like to see people share with other people and support other people. And I would like it to be easy to replicate, so easy to train how to build your own personal processing plant. Local materials, as I mentioned before. So just, instead of shipping things from halfway across the world, let's try and do all of this wherever you are. Same for machining and manufacturing. Biodiesel is pretty basic. It's, regular plumbing parts. But for bioethanol, it's a bit more complex. So we're looking at, using the advantage of technology to solve those problems. Fab labs are really popular in Costa Rica. There's a lot of really good, really well kitted out fab labs. And so we're looking at how we can reduce the cost by, assembling the parts ourselves, the complex parts, using those facilities. And open source. We all know why open source is good. It's resilient to legal challenges, no one to sue, no barrier to adoption, it's a level playing field, and it has true potential for viral growth. Now, there are plans out there that meet all of that criteria. So cheap, small, simple to construct, simple to understand, built with local materials and local machining, but it's not open source. But I do mention it here because I think that it's a good place to start. I'm not associated with these people at all. It's utahdieselsupply.com. So the plans are from a couple of $100 to about $800, and you can build the plant for about $1,000 to $10,000. This is one made with a hot water unit. This is a reactor, so you just keep the heating element in it, add some plumbing, and away you go. There's one there. Another one. This is the next one up. It's made of a couple of 55-gallon drums. You just weld them together and solve the problem that way. You can find 55-gallon drums just about anywhere in the world, and some basic welding skills and you're away. This is the one I like. You take these propane tanks. Propane tanks usually are highly regulated and they have a lifespan, and when that lifespan is over, they usually sit somewhere and rust. But if you can get your hands on them, you can turn it into this, which will produce about 250 gallons of biodiesel a day. So the bioethanol plant, this is the website of my friend in Costa Rica, ecoethanol.net. His plant cost about $275,000 US, which is obviously way beyond what I want it to be. I want it to be affordable by just about anyone, so we need to get that cost right down. So this is his plant. It sits inside a shipping container. The piece at the front there is it's actually a food processor that does the mulching of the biomass. The biomass that he's using is the cores of pineapples that come out of a cannery plant. They just throw the cores away. So it's high in sugar. It's perfect for making bioethanol. We put it in there and process it, cook it, ferment it, and distill it. The stills are at the far end. That's the stills there. And you can produce bioethanol. Testing station, make sure the quality is there. So I see our role as hackers to create, facilitate, militate, and rehabilitate, or SUFMR for short. In the creation process, we need concepts, the processes, the plans, from the whole plant to the smallest component, the software. We need to package this in a way that we can distribute easily and out-create those that have an invested interest in the problem. Facilitate. So this is about providing materials where we can, assisting with fabrication where that's required, doing ECU programming and giving away the code and the instructions and so on for free. It's about producing kits, sharing and supporting each other, training each other, and having fun. Militate. Tell your friends, clump together. I like the idea of the Roman military model. Everyone else in the ancient world, if they wanted to have a war with someone, would have to get all of their troops together in one place, and they would train for a few days, and then they would go into battle very unprepared. Whereas the Romans worked out if you had 6 men in the tiniest village, you could put those 6 men in a line. The first one would be a javelin guy, the next one would be something else, and so on, and they would train as a line. And then when they came together, they just put all those lines together. And suddenly they had a highly trained, very efficient military machine. We want to do the same with this kind of thing. So in small groups, get someone who's good at car hacking. Get someone who is more interested in the fuel side. Get someone who has a real interest in chemistry and so on, and clump together and make it happen. Lobby government, campaign, advocate. Never hurts to do that. Promote what you're doing. I think this is what the revolution might look like. And rehabilitate. So assist those in fossil fuels to repurpose their infrastructure, capital and energy and resources into something that will help humanity, not harm humanity. I think if we get started, they'll have to follow. So let's get started. Forgive. Give back. That's a permaculture principle. So share your experience and your knowledge, pay it forward. And this is the plan. The plan from here is to set up a lab for biofuels experimentation. I hope to do this in Costa Rica. We'll be prototyping different plants and so on. We'll be looking at vehicle modification. We've already started gathering data for that. We've worked out what are the most common models and makes in Costa Rica, so we know where to start with that. We need people to contribute all these things: biofuels expertise, sourcing of waste biomass, engineering of components, fabrication labs, ECU hacking, car mechanical expertise, and funding where appropriate. A note on legality. I don't know what the legal status of doing this is in wherever you come from. What I do know is that in the USA and New Zealand, it's very straightforward. You just apply to the federal government for a license, and pretty much within a couple of weeks, you get it sent in the mail and you're away. Your mileage may vary elsewhere. I don't know what the regulatory environment is like here in Germany. But it is an eco-friendly country, so I would hope that it would allow for this possibility. If you do know the legal situation, please let me know. I would like to be able to gather that information and publish it. Okay, questions?
Please line up at the microphones if you have any questions. We have little time.
Thank you for your talk. And I want to add that running a car on rape oil is perfectly legal in Germany, because there's a community who tried to run cars on rape oil maybe 10 years ago, because the prices of rape oil went up. I also had a car that ran on rape oil. It was a BMW E35 with a 525 TDS engine, because it has a pre-chamber engine, and these engines were built until 1999, and this car died because the synchronization chain broke. BMW told me that if I asked about changing the chain, because the car had 300,000 kilometers, they said, no, you don't need to change it, it lasts an engine life. And so it lasted another 20,000 kilometers, and then the engine broke. And so, but there are some drawbacks, because you need to completely redo all the sealings in the injection pump, and you need to reheat the fuel, because otherwise you will break the injection pump. So it's not that easy, but you can do it with a heat exchanger that heats the fuel from the coolant water. And so you can do it. And there's a website where there's a forum in Germany. It's called FSMO, fahrenmitsalatÖl.de. And they did a lot of experiences, and the best cars to use are the old Mercedes cars that have inline injection pumps. So you have, maybe if you have a 6-cylinder car, you have 6 actual pumps in the line, like a truck. And these pumps are extremely rugged, and so you can simply use these old cars. So excellent. The best thing to use.
Thank you. So that's a solution, rapeseed oil as a straight vegetable oil. Yeah.
Any other questions? I think where I'm from, the Netherlands, From what I'm told, we can't drive on biofuels because the government is afraid they're going to miss their taxes. So, well, thank you, Olaf. Thank you, Gustav. That's the name. Great talk. I'd like another round of applause for him.